Here we're going to look at how to write the function form when you're given a graph. That function form is here where the f of x equals, and then you write the function. Now these are translations of a parabola, this one is, and it's nice to know the parent functions, a few of them. The parabola, absolute value, square root, cubic root, and then the cubed function. Those are just a few. Now, and you want to know some points with them though on the parabola. So if I scroll down here, you can see some common points that you should know. Like the parabola has the 0, 0, the 1, 1, the 2, 4, the negative 1, 1, and the negative 2, 4. Those are 5 common points that a parabola starts with, right? And what's nice about that is, look, the first point here is the vertex, and then if you go over and up one, that should be a point, and that should be a point, right? And the function for that is f of x equals x squared. That's the function notation. And so my a out front is a 1, right? And it hasn't been moved at all. Okay, so knowing some of that for the absolute value and all those easy graphs like that is helpful when you're trying to translate them. So let's go back up here. If I look at this now, I see that it's been translated over to the left 1, 2, right? 1, 2, and then has been translated down 1, 2, 3. So there's the vertex. And now I check to see, has it been expanded at all? Has that a value been manipulated? And if it has, then this point will be different, but it's not. It's over 1 and up 1, right? 1, 1. It's just like if it was right here. 1, 1, 1, like the parabola would be right there, right? And then go through 2, 4. Well, let's see, does it go 1 and 1? Now if I went over 1 and 1 and then over 2, it should be up 4, right? Because 2, 4 is 1, so go to the left 2. 1, 2, 3, 4. Yep. 1, 2, 1, 2, 3, 4. Yep. So this is a regular parabola that's just been shifted to the left 2 and down. So parabolas, when you're shifting left and right, that means you're affecting the x value. So you must affect the x value 2. So I write x, and now it's not minus 2, but it's plus 2. And that's counterintuitive whenever you affect the x, because that means now in order to make 0 at that point, I have to put a negative 2 in, and that would bring it here, shifting it left, but then shift it down 3. So I have to put my parentheses around it, squared, and now subtract 3. That subtract 3 on the end there is affecting the y values, so it makes you take 3 away from your y's, and that puts you right there. So this is a function form of a parabola that has been shifted to the left 2 and down 3. Okay, here we go. We have another parabola, and we want to write the function form of this parabola. We notice again it's been shifted, but this time it's also been reflected, right? And so we need to go in the order of operations when we're trying to write this, because you want to think about what has happened to this parabola. The first thing that has happened is it affects the x, right? You always affect the x right away. So it's been shifted to the right, 1 spot, 2 spots. So I need to show that. Shift to the right. Not plus 2, but minus 2. Then you put your parentheses around that, and then you square it. So that's a parabola that's shifted to the right. It would look like this. Okay? Alright, well then what happened to it? Was it moved up? No, moved up is the last thing you do because you add 1 at the end, right? So it's actually been flipped over. So we kind of want to show this. How did it flip over and go through that point and that point, right? It's just been flipped over from my blue line. So to flip something over, we need to take all the y values, this one right here, and all these guys, and make them now opposites. So the y values being opposites, this is f of x, which is y. This is now my y value. To make it opposite, I put a minus in front of it. So far I have f of x equals the opposite of x minus 2 squared. Okay, that's moving to the right. That's flipping it over. My last step to make this red line is now I just want to move it up, right? So if I move it up 1, I move it from here to here, and then I follow straight down, right? And this way. And that creates the parabola I have. So I move it up 1. So this is in the order of operations again. Come in, move it to the right, flip, finally add 1. I kind of forgot to mention to make sure to check that it wasn't, there's nothing else other than a 1 out front, but you can see that here, right? It just, similar to the regular parabola, up over 1 and up 1, it just went down 1 and out down 1 and to the right 1. So it's there, it still hasn't been shifted, it hasn't been expanded or contracted at all. So this is our equation. Let's look at a new type of graph. Well, this one is a cubed root graph. It's laying on its side, it's been shifted over, and then something else has happened to it. So let's look at what the graph looks like normally. The cubed root graph normally looks like this gray line. Starts here, 0, goes through 1, 1, right? Because the cubic root, I should be saying cubic root graph. The cubic root graph, if you put 1 in, you get 1 out. 0 in, 0 out. Negative 1 in, negative 1 out. Right? Okay, let's go back here. So I have this as a cubic root graph. Now I need to start shifting it. Well, I said that it has shifted 1 unit to the right, so I show that. It goes always affect the x. So I have to have the x and then under the radical. There's the cubic root, it affects the x. It has to be directly affecting. That's different than this. See? That's not affecting the x. The x gets cubic root first and then minus 1. That's a move down, and we don't want that. Okay, so now I've moved it to the right, but now I also have to deal with this doubling, because it's just right now, it's this one right here. It goes there, and it looks like this. But that's not the graph I have, you see? It's actually stretched out. Look at that. That's 1 becomes a 2. So now I have to take that y value, and I have to multiply it by 2. Look down here, and remember f of x is y, so this whole thing is y. The whole thing, right? That means f of x is y. So this is y. If this is y, I want to double it, then I need to put a 2 in front of the outside of it. 2 times the cubic root of x minus 1. And then this would be representative of our new function in red here. It's been moved to the right one, and all of the outputs have been doubled, therefore vertically stretching it. Alright, let's have you try one. So, look at this graph. See if you can write the function form of this graph. Always start out with f of x equals. First determine what type of graph it is, right? And then go from there. You should pause it and then try to do it yourself and write the function form of this graph. See how it's been shifted and flipped over, etc. And then push play and see if you're correct. Okay, so it has first been shifted to the right one, and then it was flipped over. So we had this graph, and then we flipped it over, and then we moved it up. 1, 2, right to there. So that's what I want to do. So shift it to the right one, flip over, and move up 2. It is an absolute value graph, how I'm starting it, right? It's an absolute value graph like this. So how do I shift it to the right? I need to affect the x directly. That's shift it to the right 1, which is counterintuitive, so I subtract 1. Then up 2, and then flip over, right? Flip over like this, which is a minus on the outside, taking all the y values and making them negative, and then moving it up 2. Knowing the order is important, but you would get the same thing if I put plus 2 and then flip over. But if you put plus 2 here, and then flip over, sometimes it doesn't always work out because you're actually flipping it over, and not this point. Remember, you're actually flipping over the x-axis. So that's why it's important to flip over the x-axis first, because if you flipped over the x-axis here, you would actually end up way down here because it's flipping over the x-axis. Well, hope you did well there, and hope this video helped.